Hi guys, we're doing mathematical induction today. So basically this is in the 3-minute course, and we're roughly 3 marks. So from the 2012 HSC exam, we've got our first example. I'm not really going to teach you much theory because there's really not much theory to go through. So basically I'm going to teach you how to tackle a few of the common types of questions, which should pretty much cover about 90% of the induction questions that you will face. Alright, so let's get started. So the first type of induction questions that you're going to face is the one that asks you to prove that something is divisible by another thing. Alright, so here we've got in the 2012 exam, prove that 2 to the power of 3n minus 3 to the power of n is divisible by 5, where n is greater than or equal to 1. Okay, so that basically is the same as saying where n is a positive integer, right? Alright, so there's mathematical induction is always a 4-step process. So step 1, you're gonna have to prove true for the basic case. Okay? In this case, prove true for n equals 1. That is the basic case, right? N is greater than or equal to 1. So prove true for n equals 1. So let's do it. So let's see, 2 to the power of 3 to the 1 minus 3 to the power of 1, okay, equals, well, what's that? 2 to the power of 3 minus 3, which equals 8 minus 3 equals 5. Okay. Which is divisible by 5. Therefore, true for n equals 1. Alright, so we've gotten that out of the way. Alright, so the next step then is to prove, well, then step 2 is just a statement. There's no proving involved. So step 2, you write. Alright, so assume true for n equals k. Since we've proven true for n equals 1, let's assume true for n equals k. Okay, so that is 2 to the power of 3k minus 3 to the power of k. Now when it's divisible by something, right, you just write equals 5, and let's just use a, right, where a is an integer. And it would have sufficed to just say a is an integer. Okay. Alright, so now this is that, i.e. that is true. This is pivotal. This is where we're gonna get your equation or your inequality, no, pretty much your equation here, right? So we're gonna get it from this step 2. So it always happens, as I said, these are very basic, and you just need to learn the process, okay? And you would be able to do a large portion of the questions that you're faced with. Alright, so step 3. Step 3 is where the bulk of your marks are going to come from. Alright, so step 3, now we're required to prove true for n equals k plus 1. Okay. Alright, so in that case, what are we required to prove? TP, we are required to prove that 2 to the power of 3. Now, when it's a k, you replace the whole k with a k plus 1. Right? Don't forget the brackets, right? A lot of kids will make the mistake of just writing 2 to the power of 3k plus 1. No, it should be 2 to the power of 3 brackets, k plus 1, close brackets. Alright, because that's a huge difference. Minus 3 to the power of, I'm just going to keep things consistent here. Obviously, the parentheses don't need to be there in that case. But 3 to the power of k plus 1. And we say it is divisible by 5. Alright, so I was going to write 5 something again, but I just say is divisible by 5. That is what we are required to prove. Alright, So what we need to do here then is we're just going to take this statement here, right? We're going to take that and we're going to have to work with it. So we go left hand side equals 2 to the power of 3. Now expand that out, you get 3k plus 3 minus 3 to the power of k plus 1. Now don't forget, you're using your indices laws, okay, so index laws, indices laws, and what you've got here is you've got a to the power of x plus y equals a to the power of x times a to the power of y. I'm just going to keep them in brackets. Alright, so that's the index law that you're going to use. So here, if you're going to use the same here, you've got this is equal to 2 to the power of 3k times 2 to the power of 3 minus 3 to the power of k times 3 to the power of 1, which is just 3. Okay. Alright, so that equals that. Now once you just break it up like that, what you need to do is then you need to go up to your step 2. As I said, this is where we get the equation that you want, right? So from here we can do something like 2 to the 3k equals 5a plus 3k. Okay, so just rearrange that. If you put that 3k over to the other side, that's what you get. And you say from step 2 or part 2, whatever you call it. Okay. Alright, whatever you do, if I'm going to do that, I should have labeled this part 2 here. Alright. So you write, oops. Alright, so that equals, and we'll just replace the 2 to the 3k with this one, right? So we've got, instead of that, we've now got 5a plus 3k. And 2 to the power of 3 is just 8 minus 3 times 3k. Alright, so what we have now equals, and we should say, since, and you put that in there, okay. After that line you put that in there, your next line should be, alright, so then that is 40 times some integer plus 8 times 3k minus 3 times 3k, which equals 40 times some integer, and that's going to be, you can take out that 3k, guys, and that's going to be 8 minus 3. Alright, so quickly that turns into 40 times the integer plus 5 times 3 to the power of k, which then you can finally take out a 5. 5 times 8 times some integer plus 3 to the k, which is a whole number. Alright, which equals 5b. Alright, b an integer. Alright, so we've got that out. Finish it off with therefore true for n equals k plus 1. Yuck. Alright. Step 4 is your final concluding statement. Alright, and I always just write the same thing. Basically, I see it as you just writing out exactly what you just did. So, since true for n equals 1, we assume true for n equals k, and then say since proven true for n equals k plus 1 by mathematical induction. Statement must be true for n equals 1, 2, 3, i.e. n is greater than or equal to 1. Bang. And that is your 3 marks.